Hello, everyone, and welcome to the Rice Elite Tech Camps webinar. We're excited to share with you some important information about these summer camps, as well as answer any questions that you might have for us. Before we get started, I would like to orient you to this webinar. In your webinar panel, you should see an option for Q&A. If you have any questions about what we are currently talking about, or anything else that is related to this program, you can put that question directly into the Q&A box. We have a panel of different people from Rice Elite Tech Camps that are here to answer any questions that you might have. So please feel free to ask questions throughout the webinar in the Q&A. To get us started, we'd like to talk a little bit more about Rice Elite Tech, but you're going to hear it from someone who is immersed in the day-to-day. We are very lucky to have with us today Kaz Kowalski. Kaz Kowalski has assumed the role of executive leader at the Rice Center for Engineering Leadership at Rice University since July 2013. He is also a faculty lecturer at the Brown School of Engineering and contributes to entrepreneurship through the AlSpark Startup Accelerator. Prior to his tenure at Rice University, he had a 20-year career in the U.S. Army. He is here with us tonight to speak more about Rice Elite Tech Camps. Kaz, thank you for joining us this evening, and I will pass the microphone over to you.
Thank you very much. I appreciate it. Thank you very much and welcome. I appreciate all of you being here this evening. I'm going to talk through some of the camp highlights, a little bit about the camp, and I'll be able to answer any questions that you may have about the camp. If you go ahead, can you please advance the slide? So the Rice Center for Engineering Leadership has been at Rice University since 2009, and we've been established to develop the leadership skills for our engineers that attend university here. And a handful of years ago, we thought it was important for us to reach out to the community and actually start to develop the next generation of engineering leaders who are going to change the way we live in the future. And we decided that we wanted to develop a summer camp. And so as part of this, we decided to grow this camp and expand it and really teach students the skills that we didn't get taught when we went to summer camps when we were students their age. We remember going to schools and having summer camps and doing some exercises, but they really didn't replicate any of the things that you'd be doing in the future in your careers. And so as we designed the camp and we just started designing these camps, we decided that we wanted to incorporate some of the content that would be beneficial and some of the skills that we thought would be beneficial for students to have as they progress through college and then further on into their careers. And some of that is coding, it's leadership, project management, things that are practical and things that they can apply in their day-to-day lives and, get a head start as they go off into their college career and into their futures. And the goal is really to inspire students to become interested in engineering and STEM, or science and technology. And that's part of the reason why we created these camps and why we continue to run the camps each summer. Next slide, please. So a little bit about our students. The goal of our camp is to provide an engineering experience or a STEM experience for high school students, ranging from 9th to 12th grade. And the goal is for students to come in and be immersed in an environment on a prestigious campus, right, Rice University, and engage in content that will benefit them in the future. Students come from all different parts of the world, all different parts of the United States. We have students that have come into the camp from internationally. The students that we have that are working with us in the program come from all over the globe. As we go forward and we talk to the classes, and I'll talk a little bit more about the course itself. The courses were designed by PhDs or technical experts in their field. And those courses were tied into, and then they're taught to the live instructors. So live instructors are students that are here at Rice University. We train them, we teach them all the content that they need, and then they, under the guidance of the faculty, teach the class. And so we're really looking for students that are really interested in STEM careers, possibly going into engineering, or people that are just not quite sure what they want to do. And this gives them an opportunity to try some of these things out and see what it's like to be an engineer or see what it's like to work in a technical field. And hopefully it sparks an interest in them so that they can decide that that's what they want to do when they go to college or in their future careers. And like I said, the camp itself is going to be located in multiple locations this summer. We have one at Rice University. We also have a session that's going to be held at UCLA in California, and another one in Atlanta, Georgia at Emory University. Now, the content of the camps is going to be the same. The experience will be the same. The only difference will be the geography. Next slide. So as I mentioned a little bit before, the program itself, as we went back and we looked at our experiences as young people, we looked at some gaps and things that, the programs that we went through many, many years ago, what they lacked. And so we decided that we wanted to incorporate content that was important, things that were relevant to engineering and technology fields currently. And we met with and we designed the program so that engineers, PhDs at Rice, or a couple of people that come from other universities would create the program and create content for high school students to design a class that takes the things that they would be needing within the first couple of years at a university or in an engineering degree and give them the basic foundation, or at least an idea and a taste of what it's like to be in those areas. And we design those courses. Those courses are, they will cover some of the content, but there are 8 tracks that you can pick from. And of those 8 tracks, we have a variety of different topics. A lot of them involve coding, but a lot of them involve hands-on things where you're actually building some components, particularly the robotics courses. We have a course in 3D printing where you can actually sit back and design parts and using a design software, and then learn how to use that software to design different types of parts and see how they can be articulated or maneuvered. We also have courses that cover some basic coding languages such as Python and C++, languages that are very popular and very widely used in engineering and in industry today. And, the camp itself comes in a couple different modalities. You can do online, there's a residential component, there's an in-person component, and the content is actually delivered by, on a daily basis, what we call live instructors. And those live instructors have been trained and they meet with and they're taught by the head instructors. The head instructors created the entire content. They train these live instructors. We work closely with these live instructors for months to prepare them for the class. And the head instructors, those are those PhDs, often pop into the class and interact with the students. But on a day-to-day basis, the live instructors are the ones that are going to be teaching the content with the instruction of the head instructors, making sure that the content is straight. And those students will be the ones that your students interact with. We vet them. We work with them for quite a long time. And that's really so that they get a high quality experience and they understand the content so that your students, when they leave with a positive feel, and they leave with some knowledge that they've gained and that they can move forward and hopefully have a career in industry in engineering or STEM. Can you go to the next slide, please? So the program itself is something where students, they don't need to know calculus. You don't need to know a lot of the high-level math. The reality is the courses are designed to meet students where they currently are, right? We understand that these are high school students, and different students are going to have different levels of experience and come with different math levels and computing levels and experiences. The nice thing about the program is that every student that comes in is going to be interacted with kind of where they are in the process. And our instructors have been taught to teach people how to get from point A to point B in these self-contained courses. So regardless of where you come in, whether you have a lot of experience or a little experience, the instructors are taught to kind of gauge the content so that you can, so it's challenging for each one of the students. Know that there's a low student to instructor ratio. It's typically 8-to-1, meaning for every one student or every instructor, there are 8 students. So if you had 24 students in the class, you'd have 3 live instructors in that classroom with them to make sure that if a student has a question or they're confused by some of the content, our live instructors will be able to help them understand the content and move them past whatever that sticking point is. In the virtual version of our class, which the content is the same, it's 1-to-5. And the reality is that students get the ability to kind of like interact with these live instructors and truly learn. The nice thing about these instructors is they are college students, they are Rice students, they're going to be UCLA students and Emory students, and they'll be able to interact with students and explain to them what it's like to be at a university, how these skills are important for them to know as they decide whether or not they go into a certain particular type of major. If how important is it to have, or how beneficial is it to have prior knowledge in Python before you go into college? And talking to the students and having them explain what it's like to live in college or to be in a college experience. How do they choose their college of choice? We actually have information sessions from admissions. We have a lot of other things that are incorporated into the camp. So there's typically 2 sessions. You do a session in the morning where you learn one of a topic. Then we have a break for lunch. We do what we call leadership labs, where you're going to learn a leadership topic. Online, there'll be a section where we'll talk about different topics. This year, we'll talk about project management. In the leadership labs, the students will be put into teams, and those students will actually deliver on a product. They'll build something, they'll do something, they'll get feedback from their coaches on how well they led the team. So it's not just about can you learn the technical aspects of whatever the product is, you're also learning what it's like to lead a team or work in a team. Then after that session, you have another technical track where you learn another component. So for every student that enters the camp, they learn 2 different tracks in the on-campus or residential programs. Now, for the virtual programs, you get one track, you either get a morning or an afternoon, and they're broken up, but you still get the leadership lessons and the leadership content associated with your track. Next slide. So I talked a little bit before about some of the track options, the tech track options, and here are the tech tracks that we're offering this summer. So we have 3D modeling and printing. So this is where students will learn Fusion 360, they'll use Fusion 360, and they'll use that to design and have printed something that they decide to print, right? So we've had students print necklaces and keychains and all kinds of things. And at the end, they actually get the printed product that they've designed. And the students will learn how to make it scaled, how to copy pictures and embed them into the design material, how to rotate it, how to change the parameters, and really understand what it's like to use a 3D modeling tool so that you can design something. This is great for people that are interested in mechanical engineering or in some type of a design, CAD. And this gives them hopefully a good basis of understanding of what it means to be able to do this type of thing. And maybe that it sparks their interest in the career in that type of field. We also have deep learning, deploying AI to maintain smart cities. And so what this is it's teaching students how to use Python and some machine learning to recognize different photographs and patterns. And so how you can make, and the idea behind this is that students can use this so that you could implement strategies to make cities become more efficient and using that. C++ for human spaceflight. This shows that there's an interaction between physics and mathematics and physical mechanical engineering to produce, results where, people are hopefully landing on the moon in the next year. And by doing this, they'll be able to calculate the different trajectories, how much the weight would be, how much weight a certain rocket could lift into space. And this one is it's a little more challenging. Students will be exposed to different ideas or different components of calculus, but they do not need to know calculus. And the instructors will share where these theories come from and which formulas are used to derive certain things, but they don't need to know calculus, but they do need to understand that, they will be exposed to those types of things during the course. We have learning Python to solve engineering problems. The students will learn how to code Python. They'll be able to draw plotting, right? So they do a live experience. In this particular one, They do heat transfer where they're boiling a particular type of food, and then they take those results and then they plot them using Python, and they actually plot the trajectory of the heat transfer on inside a program. We also have the trifecta tech, which is the Internet of Things, and this one shows you how to absorb or collect data from the internet. And they actually get a sensor, and the sensor collects temperature data, and then they use that to plot the data, and they can use that to do predictive modeling. We have robotic engineering, where they actually design or they build a robot. So it's not an entire robot, but those robots are the engines that actually maneuver the robot. So as you can go through, there's different components. They'll have to be a large skeleton, but you have to have the motors that actually control those. The students will learn how to control those motors using code, and they'll actually build the circuits, and then they'll run those circuits, and they'll run the motors so that they can show how a robot is actually built, right? It's not just the arms and the actual exoskeleton, it's the motors that actually articulate the movements of a robot. And then we also have robotics engineering 2, adding sensors to your robot to see, hear, and feel and smell. And this is very similar to this. You're going as the previous one, instead of using the motors, you're going to be putting different types of sensors to run the motor, to run the robot. And then finally, self-driving technology. In this one, they have the ability to code, build a self-driving car. So they're going to have the ability to sit in there, build the code so that the car can receive different sensory inputs and then maneuver around obstacles without any interaction from humans. So the goal is to show them all the progressions and the steps necessary to build a self-driving car. So that's a lot of information. But as you can see, there's a wide breadth, and these are not your typical summer camp classes. They go a little bit deeper than what you would typically see, and that's something I think is a benefit to attending our camp. Next slide. Okay, so is this one me? I think this one's me, right? So student
You're
life.
on a
So
roll, Kaz. We'll let you keep
okay, so
going.
I can cover it. Okay, so student life. So students, if you take if you're attending as a residential student, you'll stay in one of our residential colleges. Rice University has 13 residential colleges, and they're all named after different people. And we jokingly say it's kind of like a Hogwarts thing, where they have a college and they have a culture. But you'll be staying in one of the residential colleges. There are people that will be staying with the students 24 hours a day, 7 days a week. Meals will be served in a traditional residential dining hall. All the students will come in and they'll eat in that residential dining hall at lunch every day, or breakfast, depending on and dinner, depending on whether or not you're a day student or a residential student. There's Wi-Fi that goes out throughout the entire campus. There are lounges, there's vending machines. We have it's a full college campus, but we have supervised activities that the camp will maintain in the evenings, and know that there's going to be people on campus to escort students to and from to make sure that they're safe while they're here on campus. Know that there's 24-hour staffing, and there's always someone available where if a student has a problem or something like that, they know exactly who to go to. And during the day, when students are on campus, there's always going to be one of the live instructors or one of the faculty members around them. And just so you know, for me personally, I spend most of my day in the camps, and I go from classroom to classroom to make sure that everything's going well. And I communicate very closely with WorldStrides throughout this entire process. And we make sure that students have a really good experience as they go through. The nice thing about this is it gives them the ability to be on a college campus and experience what it's like to live in a college dorm room, in a college building, eat in a dining hall, sit in a classroom, see all the amenities associated with a university. And it really enhances the experience for them so that they really see what it's like, where it's a distinctly different experience than a high school. And the nice thing about our coaches and our live instructors is that they're college students. They're a handful of years ahead of your students, but they've been there and they've experienced what it's like to be by yourself, and they've experienced what it's like to have to do homework in the evenings and wash your clothes and things like that. And those are the types of stories that they talk to the campers as the campers, spend a week with them. And it's a really positive experience because they get to talk to them in a way that is really educational, um, without it being educational, if you know what I mean. So I think it's a really good experience for our students. We also have a couple of other information sessions where we have admissions come in and they talk about generalized admissions, getting into high-end universities or just in universities in general, like what things are typically looked for depending on where you want to go and the type of school you want. And they'll talk in general what it looks like to apply for a university. So I just kept going. So next slide.
Before we go to the next slide, we have a question for
Yeah,
you.
absolutely.
So you had mentioned that the 3D printing course would be beneficial to an ME major. Can you
Yes.
ID which course is geared toward which specialty? Things like CE, ME, AE, EE, etc.
Okay. So if can you go back to the slide with the classes?
Sure can.
Okay, so for 3D printing, oh, one more. That one right there. So for 3D printing, we say that it's good for mechanical engineers, but civil engineers would also use that, right? So they're going to use different type of modeling. Even though you're 3D printing a model, the type of modeling software that you would use would be similar to things that you would use in civil engineering. But I would also say that as you go forward, Python is one of the most widely used programming languages in all of engineering, regardless of the discipline. From electrical engineering or mechanical engineering, you could go into robotics, either of the robotics. The self-driving car would also be for electrical engineering, mechanical engineering, computer science. Python would be for computer science. C++ would be for computer science or data science. Deep learning is also Python, but they're also covering a little bit of machine learning in there as well, which is, what people commonly refer to as like AI. But machine learning has been around for a long time, and there's going to be some machine learning also in the trifecta tech as well. So I think depending on, if someone's interested in a very specific type of engineering, in all honesty, unless they already know the area that they have interest in, there's benefit for people to see different types of engineering. If they're unsure of what they're interested in or unsure of what they would like to do, the best thing to do is say, do one that would be more aligned with mechanical engineering, say a robotics one, and then do one that's more coding based, a Python class in the afternoon, so that you get exposed to multiple different types of engineering. And it might help you decide what you want to do as far as a career. I don't know if that answered your question. I hope that did.
I believe it did. And if anyone else has any other questions, please feel free to put those in the Q&A as well.
So they keep coming in. Okay, so there's one I see, Python with machine learning Python course would be beneficial to him. Yeah, I think it would work, but I think he could also go into the mechanical engineering one, because the mechanical engineering one is not just going to be how do you learn how to do Python, it's now how do you apply Python. Just so now that you understand how to do the code, now here's a way that you can do a practical application of what you've learned and use that result to show what you can do with it. And I think that's the coolest thing. So you would do the Python course for mechanical engineering. I think it's using Python to solve mechanical engineering problems.
Thank you.
Okay, I'll stop.
As we'll come
I'm
back
willing
to
to
you.
answer any questions. I'm sorry, I kind of went a little bit long but the whole point is really to be able to answer questions that the parents may have or people that are interested might have.
And that's a great plug. We are getting toward the end of the webinar, just a couple of more slides to share. So if there are any other questions that you all have, please put them in the Q&A. And while we have our resident expert here, we can get those questions answered for you.
I did see one about the leadership component. So the leadership component, I think I may have touched on this, but it's really about having them lead a team, right? So as engineers, they're going to be working in teams for the rest of their career. And so being able to lead a team, communicate effectively, make decisions with the team, those are the types of things that we cover inside those leadership components. So as they lead the team, they'll lead either well or they might not do so well, and we'll give them feedback on what they could do to improve. And that's really what the leadership labs are designed to do. If you're in the online version, because they can't do the interactive hands-on thing, what we do is we teach you how to do project management, which is also a very useful skill.
Great, thank you. So here on our slide are some of the feedback that we've received from our students and parents. For those that have attended our program that are now alumni, we do give them surveys to let us know how the program affected them, as well as measuring the impact that the program had after they've left us. So for our students, 84% of them said that the courses that they took with us helped to better understand the options for different careers that they have in the field. 97% of them felt that they had a deeper understanding and better knowledge about the program content. 84% of them said that their instructor made learning fun. So thank you very much to Kaz and the rest of your team for that. 97% of the students agreed that their instructor really knew what they were talking about and had strong knowledge about the curriculum and activities. And from the parent side, all the parents that we had surveyed said their students' experience either met or exceeded their expectations. To further build on that, we also have some direct quotes from some of these students and parents about their experience at Rice Elite Tech Camp. One that I really want to call out was from Victoria, who is in the top left corner, and saying how much that they didn't know what to expect when they came to the camp, but how much they ended up receiving from it, especially that everything was very hands-on. And that's really what we pride ourselves with. The fact that they got to experience some things that most students, especially at this age group, don't get to do, and get to do it directly with the faculty and those related with Rice University was such a huge impact for those students. And we're really excited about all the course offerings that Kaz talked about for this upcoming year and hoping to build upon the experiences that we've already given. So in case you're wondering, registration is currently open. We also have a QR code right here on the screen. If you would like to scan that, it'll take you directly to our registration page. So there's only 3 steps in registering. So you can either use the QR code on the screen, or you can go to our website, which is ELITECamp.Rice.edu. You can go to our website and click on any of the Enroll Now buttons, or you can speak directly with one of our Office of Admissions agents. And that number is 844-794-4427. So to close this out, I do want to let you know about the dates for some of our programs. As Kaz mentioned, we'll have 3 locations for our live delivery, which is going to be in Rice University in Houston for 4 of the sessions in the summer. We'll have 1 session at Emory University in Atlanta, Georgia. We'll have a June session at the University of California, Los Angeles. And then we have our synchronous virtual delivery. So if for some reason those locations are not any place close to where you are, or for another reason you just would rather do it virtually, there are also options there. So thank you again for being with us today as we speak more about Rice Elite Tech Camps. We'll see if there are any other questions that are coming up that we can answer for you live while we have everyone here. Kaz, I have another question for you. Can you explain what course would be suitable for a career in satellites and rockets?
I would do C++, human space flight. So that one right there, because you're going to be talking about trajectory. They're going to be calculating parabolas. They're going to talk about the gravitational pull around the Earth. And so definitely that's the one. That one. And then, you know, because you get 2, there's also another one. So I would do that one and probably anything that's Python based. That would be my recommendation.
Thank you.
Any other questions?
I see our panel moderators are answering a lot of the questions. There are a few questions coming up about some of the evening activities the students are doing, so I know that they're answering those right now. Here's another one for you, Kaz. How far deep do they go in 3D design?
Well, I mean, they essentially have to pick something that they want to design, and then they design it. So as far I don't know what you mean by how deep. They use Fusion 360, so it's a modeling tool. So essentially, what they'll do is they'll learn how to make flat pieces, round pieces, 3D, and then they'll talk about how dense the product will be printed. They'll talk about whether or not it has different types of textures and things like that. So they actually cover quite a bit. And they do use Fusion 360. Fusion 360 is the one for choice because you don't have to download any additional new software. It's something that you can use, and it's on a browser base. So that's the reason why they chose to use that. And what will happen is they'll design the part, and the part will be they have to operate within a budget. And then when they design their final part, the part is printed in whatever material they use and mailed to them at the end. And we've had people try to mail 3D print things out of steel and aluminum and you name it, but they do all different things, mostly steel, plastics, different type of resins, and they go from there.
Hey, thank you.
So
Do the
here's a,
faculty members deliver any of the courses,
they do
or are
not.
they all delivered by undergraduates?
So what happens is the undergraduates are taught by the faculty members, the content in the class, and then those students are actually teaching. So we actually have a variety. So not all of our live instructors are undergraduates. They range anywhere from sophomores to seniors, graduated seniors, and we also have graduate students that are working for us during the summer. So it just depends on the class and it depends on the course. The faculty sometimes come in. I know, and particularly in the robotics course, David Trevas, he comes in at least once a day, pops in, talks to the students and helps them them work through some of their problems. But not all the faculty are available every day. But oftentimes what they'll do is they'll do a Zoom session where they'll Zoom into the class. And so I think that, so the answer is, we have a variety of different live instructors that range anywhere from sophomores all the way up to graduates and graduate students teaching the classes.
For those that are trying to do the synchronous virtual delivery classes, how will those differ from the in-person classes?
So the only real difference is the fact that instead of doing the hands-on leadership lab, there'll be more of a presentation lab where we'll cover project management and a topic like that, as opposed to the hands-on activity. So you would go through, the content is going to be the same, the instruction will be the same, other than it'll just be in a virtual modality. So the classes are technically the same, other than the modality and the fact that the leadership component is going to be a little different.
Great. We have a specific question about robotics engineering 2, and if you could share any of the activities that might occur in that course.
So what they're going to do is they're going to put sensors on the robots and then have the sensors tied into the control mechanism. So whereas the other one, they were having them the ability to increase speeds and move different motors, right? So now you're going to use different sensors, and the sensors will be able to identify light or smell or sound, and then use those so that they can maneuver the robot. So the robot would be able to operate using sensory as opposed to direct control.
Great, thank you. We'll do a last call if there are any other questions that you all have. Again, we have the expert here in the room, and we don't want you to walk away if there are any questions that you have that are unanswered. So we'll do a last call in case you have any last minute ones that you can answer live before we adjourn. Kaz, in the meantime, is there anything else that you'd like to share with everyone?
I think what I would say is that this camp is, I feel, unique. The content was, created by PhDs, whereas a lot of summer camps are not. And we take pride in the fact that our students are come from the universities that are running that are where the classes are actually being taught. And we train them very well, and we make sure that they fully understand the content, and they provide a really good experience from a mentorship perspective for your students. And I think they're a great role model.
We did get another question that came in. For the satellite programs, will there be Rice administrators or senior staff on site?
Yeah, so what we will do is, as people are on the campuses at UCLA and Emory, we will have a Rice person there. Yes.
Great. Last call for questions. See if there are any others that come through. All right, it looks like we've answered all the questions. Kaz, I'm going to throw it over to you for any closing words.
Well, I'd like to say thank you for giving us some of your time this evening. I know it's a big decision to decide what you wanted to do, or what camps to have your children attend. I'd like to say that, as you go through this process, we put a lot of time and effort into making a camp fulfill the needs that was missing from when we went to summer camps many, many years ago. And I hope to see your students here, and I hope to see you here at Rice and in our other satellite locations. I really appreciate it.
Great. Thank you so much for being here with us today, Kaz. And thank you all for attending this webinar. This webinar has been recorded, and it will be available approximately 1 week from today. If there are any other questions that you have about the program, please feel free to visit us at our website at ELITECamp.Rice.edu, or by calling our Office of Admissions at 844-794-4427. Thank you again for stopping by and learning more about Rice Elite Tech summer camps, and we hope to see you and your child at a future program very soon. Thank you.